All right, today we are focusing in on the displays for quantitative data. So in section 2.1, we talked about qualitative data, and some of the displays for qualitative data were bar graphs, pie charts, Pareto charts, all of those that we discussed in the previous section. So the popular displays for quantitative data, we are going to really just focus in on two of them, but the popular displays are, and we're going to type them out here, histograms, and then relative frequency histograms, and, sorry, and then we also have dot plots, which you did, early, probably like fourth through sixth grade, perhaps, for dot plots. The other big one is a stem and leaf plot. So right here are the types of displays that we're going to focus in on for quantitative data. It is very important that you know which types of displays go with which type of data. So I think I said that in the last section, but I'm saying it again. Make sure you're able to state, which ones are for quantitative data and which ones are for qualitative data. So we are actually going to focus in on the first two. So knowing that a dot plot or a stem and leaf plot does quantitative data is something you will need to know, but we're going to focus in on constructing histograms and relative frequency histograms. The other displays we're not really going to make very often, but we just need to know that they are options. So looking at our definitions for histogram, a histogram is a graph consisting of rectangles, and the rectangles have to have equal width. So we're not having some, that are wider or skinnier than others. The main visual difference, obviously there are lots of mathematical differences, but the main visual difference between a histogram and a bar graph is that on a histogram, your rectangles are going to touch each other. So they're going to be right next to each other. In a bar graph, they should not. There should be space between. So that should be a visual cue. You can see down here in these examples that we're going to talk about momentarily, all of these are histograms. And see how you've got lots and lots of rectangles, but they are all right on top of each other. So they touch each other. The heights of the bars represent the either frequency or relative frequency, depending on which type of histogram we are talking about. We call the categories into which the data are grouped classes. And within classes, you are going to have lower class limits and upper class limits. So your lower class limit is going to be the smallest value within a class. And I'm going to show you an example here once we get all of these definitions typed in of what it would look like in the frequency or relative frequency distribution. And then obviously we would carry that over into the histogram itself. So the smallest value within a class is the lower class limit. As you might expect, the largest value within a class is going to be what our upper class limit is. Class width is the difference between consecutive lower class limits. So this, and I'll illustrate it once I've got an example going up here. But this is a common mistake that I see amongst students, is that sometimes they try to calculate class width between the lower class limit and the upper class limit, and that is not how it's calculated. We take two lower class limits that are right next to each other. It's that difference that is the class width. So we just have to be really careful with that. So when we are looking at, I'm going to make a frequency distribution over here on the side and kind of show you how we would define these things within that particular example. All right, so here I've just come up with an example of a frequency distribution, and let's see, let's say that this had frequency 3, and then this guy 1. Why will not let me draw? Sorry, trying to get it to not pick up there. Okay, 1. And then in here we had 0, let's say, and 1, just to make the numbers small and easy. So the classes are these individual groups of numbers. So 60 to 64.9, 65 to 69.9, 70 to 74.9, etc. So the lower class limits in this case would be 60, 65, 70, and 75. The upper class limits would be 64.9, 69.9, etc. The class width, what I was saying, is the difference between consecutive lower class limits. So the difference between 60 and 65, between 65 and 70. It should be consistent. So in this case, the class width is 5. There are 4 classes with a class width of 5. There are going to be some rules that we use when we are trying to create our own histograms, and sometimes they'll give you more restrictions than others. So sometimes they might say create a histogram with 7 classes and the lowest class, lower class limit is 10. And so then you kind of like know where to go. But when there are less pieces of given information, a couple things that are really important to understand. First, you cannot have an empty class at the beginning or at the end. So here I purposefully picked a 0 in the middle because that's allowed. That's just going to create a gap. So it's going to look, a little bit like a bar graph, and just that particular piece, because there's going to be space. But you cannot pick a class width where you're going to have empty classes at the beginning or at the end. So if that happens, you have done something wrong. Either you've got the wrong number of classes, if they specified that, or you've picked an incorrect class width. So when we are looking at this, there are a couple different ways that they can write the classes that I want you to be aware of. So this is the most common, what I've done here, but we can also use interval notation like you do in algebra-based math with the parentheses and the brackets. So you might see something like, let's say instead of what I have here, maybe you see a bracket with 60 and then comma and then 65 with a parenthesis on it. So this is another way to write the classes. And in this case, the next class would start with another bracket at 65. So here's the deal. We can do this when we use parentheses and brackets because that implies included and not included. But if you're not using that type of notation, then that would be why this original ended at 64.9 because you can't have overlap. So I can't include 65 in the first class and in the second class. So brackets mean to include and parentheses mean to not include. So that's another way to write it that gives kind of that option of where you know specifically, because I have to know where to put 65. There can't be overlap. Otherwise, I don't know whether to put that in the first class or the second class. So that's just another way that you're going to see and be expected to be able to write those. Another thing that we see is what is called an open-ended table. And that is where the either the first class has no lower class limit, or the last class has no upper class limit. So that would be like if I were to continue, with this table, but in the last part, instead of saying 75 to 79.9, an open-ended table, you might see something like greater than, why will it not let me write? Sorry. So it might be something like this where it says like greater than 75. Obviously if it's the first class that's open-ended, it would just be, less than 5 or less than 50 or whatever the case may be. So that's what an open-ended table would look like. When you go to convert a frequency distribution into a histogram, you use the lower and upper class limits. So when I would go to make this into a histogram, I would, of course, make some axes, and then I'd be putting in rectangles. So here, give me a second while I turn this guy to make it vertical. So let's say that I'm, using this as my histogram. I would label over to the side. So, I would have frequencies on the left side. And so it might say, 1 over here, and then 2, and then 3. Sorry that I'm kind of smashing this all together. I just really want to make sure you understand how these relate to each other. So this is why I picked small numbers or small frequencies. So if I were trying to make my values here for the bars, here would be my first one. And of course you can see they're filled in. You wouldn't leave them empty like this, but I'm trying not to cover everything up. So down on the bottom where I would go to label, I would have over here is where I would put 60. Sorry, it's really difficult to write with this. And then over here would be 65. Now, because I can see the the frequency distribution, I know which values go in which bins or which categories, which bars. So the next one, 65 to 70, if I go to create that guy, I know it should only have a height of 1. So when I go to bring it over, it's going to be right next to it, same width, but it would only go up to 1. Then I would have an equally spaced size for the gap, because again, the only reason those aren't going to be touching is because there's a hole, right? So if I adjust this to make them look equal size, I could continue out. This would be obviously going to 70, 75, 80, and this is what my histogram would look like. So converting back and forth between the frequency distribution and the histogram. I, of course, just made up these values randomly. They don't necessarily stand for anything, but we would, when we make the histogram, label our axes with whatever it stood for. So let's say these were heights. We would put along the horizontal axis height in inches. Along the vertical axis, we would put frequency. The same thing happens if it's relative frequency. So you would just label that vertical axis relative frequency instead of frequency. So you're going to need to be able to identify the shape of data based on its histogram. So there are four main shapes that we're going to talk about today. The first one that you see there, we call two different things. Right now, we're kind of focusing in on calling it bell-shaped, but later in the course, we will focus in and call that a normal distribution. So I want to at least introduce that term at this point as well. So this is bell-shaped, which, you've been looking at bell-shaped data for many, many years. So there is data that can be, so bell-shaped data, normal distributions are both bell-shaped and symmetric. But you always have to choose the best. So you can have data that's symmetric that is not bell-shaped. So this is bell-shaped. It's also symmetric, but you could have, two, high bars on each end and low bars in the middle. That would be symmetric as well. You always need to choose the best option. So the best option here would be bell-shaped. This next one is the one that people always forget, so don't let it be you that forgets it. This is called a uniform distribution because all of the bars are approximately the same height. They do not have to be exact. And of course, the bigger the number, the more leeway you have as far as how off they can be. But if they look all very similar in height, we call that a uniform distribution. The next two distributions are what we call skewed distributions. And when we name something skewed, we need to name which type of skewed it is. So these two represent skewed left and then also skewed right. So it's kind of the opposite of what you would think. So a skewed distribution is named for its tail, meaning where the lowest bars are. It is not named for where the highest bars are. So the clump here is on the left, the tail is on the right, so we call it skewed right. A trick that people have put out there a lot is that if you think of the way your toes look on your feet, your right foot, has the taller toes on the left side. So skewed right kind of models the right foot, where skewed left models the left foot. So again, this is skewed left because the tail is on the left side. The clump is what's on the right side. All right. As I always do, I've got stat crunch directions in here for you for how to create histograms. And I've put in here how you can create frequency and relative frequency distributions for both discrete data and for continuous data. So again, we've talked about discrete and continuous in chapter 1. Discrete is typically things that we count. Continuous is things that we measure. So this can kind of help you to create those. Again, in your homework, if you prefer to create some things by hand and others in StatCrunch, that's fine. You will obviously need to know how to use StatCrunch when you get to your exams. So I suggest trying to use it for at least, half of the problems that you have. Some of them you won't have a choice and you will have to use StatCrunch. So remember, when you're submitting that, you can copy and paste them into a doc to then share with me if you don't have the ability to print them. So we're going to look at two examples. Example 1, the following frequency distribution represents the sprint speed in feet per second of all players in Major League Baseball during the 2018 season. So what this has for us here is a frequency distribution, because this is just straight number of players. It's not percentage or a decimal. So we know that this is frequency, plus it says it in the directions. So this is just making sure that we understand our definitions, not by regurgitating them, but being able to identify them from an example. So identify the number of classes. So number of classes are the number of little categories that we have here. So in this case, 1, 2, 3, 4, 5 classes are what we would put for that. Identify the class limits. So this is asking us to actually list them. And it doesn't specify lower or upper, which means that we are going to need to do both. So I'm going to type those and bring it over here. So for lower class limits, remember, those are how the classes start. So 22, 24, 26, 28, and 30 are our lower class limits. So I list all of those as the lower class limits. Then, because again, it just said class limits and did not specify, I'm also going to list the upper class limits. So for the upper, we have 23.9, we have 25.9, we have 27.9, 29.9, and finally 31.9. And I'm going to have to move this over. There we go. So there are our lower and upper class limits. C, identify the class width. So again, be careful with this. This is a common mistake that I see. You want to subtract one lower class limit from the one before it. So in this case, 24 minus 22, which is 2. So do not do 23.9 minus 22. That's going to give you 1.9, which is close, but it's not the answer. Class width goes between consecutive lower class limits. All right, example 2, the following data represent the default rate on student loans for a random sample of 40 colleges or universities in the United States. So this guy, again, because I'm trying to show you examples with StatCrunch, this is from number 27 in the text. So that way you can upload the data more easily. Remember that when you go into your Canvas under modules, you can, under data sets, direct links for homework problems is the first one you should see. And when you are on that, that is where you pull the links. So if you are wanting to follow along and upload this data, we are still in chapter 2. You go down to section 2, number 27, and you pull this link when you go to upload it into StatCrunch. I won't need to do that because I've already uploaded it, so it's already in my data. So when you already have something uploaded, so let's say you like are doing something in the homework and then you need to ask me a question about it the next day, you don't need to go back to the Canvas links. You can just go into My Data, and then that will allow you to pull any of the data sets. So make sure you name them in a way where you can actually see it. So you can see I named mine 2.2 example 2, and now I have selected it, and now all of that data that is on the notes is now also in my StatCrunch. So let's go back over to the notes. It says if 7 classes are to be formed, choose an appropriate lower class limit for the first class and a class width. So they're telling us that we need to select our own class width. And so the way that we do that, I'm going to kind of underline and draw an arrow over here, because there is like a little baby formula that we use that is helpful for this. So let me bring that guy over. And we, when we are doing this, what you're going to do when you're creating your own is you're going to do the maximum value and subtract the minimum value. Then you are going to divide by the number of classes. So most of the time, they will give you either the class width or the number of classes so that you don't have to do both. So in this case, we know how many classes we're using. It says 7, so we can use this formula. Now, you have to round up. So that's the key. How much you round up might vary. You know, you have to, again, make sure you're following the rules that we talked about with the empty classes. So you have to make sure that you're not going to have an empty class at the beginning or the end. So sometimes that might be rounding up to just the next whole number, but maybe you're like, you know what, I'd rather count by 5s than 4s. And if that fits, then you can do that. Yours doesn't always have to be the same as someone else's. So in this case, when I look through all of this data, I am looking for the largest values. So search through this to see if you can find the maximum. Right now, I think it's 27.3, but I'm going to double check to make sure I don't see anything bigger. Okay, I do not see anything bigger, so I'm going to do max, which is 27.3, minus the minimum, which is 0. And we're going to divide that by the number of classes, which they've told us is going to be 7. So when I do that, I get 3.9, and it says then round up. So the next up value would be 4. So we can certainly count by 4s. Again, if you found that you could make 7 classes without an empty class at the beginning or end and counting by something else, then you're allowed to do that. The appropriate lower class limit is 0 because you can't choose a lower class limit that's going to exclude any of your data. So 0 includes my lowest data, and I'm going to go with a class width of 4. So we are going to construct both a frequency and relative frequency distribution from this data in StatCrunch. Then we're going to create a relative frequency histogram, and then we're going to use that to help us describe the shape. So Here are our instructions. So for frequency and relative frequency distributions, it says enter the raw data into the spreadsheet. So, and it says the same thing regardless of whether it's continuous or whether it's discrete. So if you have not uploaded the data and you want to here, then pause the video and come back once you've got the data in there, because I'm going to go over here. Remember that there are two different sets of instructions based on discrete and or continuous. This is going to be continuous data. So I'm going to follow those instructions. So the raw data is already in the spreadsheet. The column variable is already named default rate. So it says select data and then bin. So data, bin, done. Then you have to select the column, which is default rate. You click use fixed width bins, because we were specifying. Now you could do this automatically if you wanted to. Have it pick where to start and end. So bin is like the class. So this is telling you what the lowest lower class limit is. Bin width is the same as class width. So we're choosing 4 for that. You always want to include the left endpoint. So that means the lower class limit is what is included. The right side is like that parenthesis rather than a bracket. Then we click compute. So notice it's created a new column there. So I don't need that notification anymore. Now my directions say select stat and highlight tables. And we are going to choose frequency. So the key is here, I need to choose the bin and not the original data, because if you choose the original data, it's going to give you a column for every separate thing, which does not work. So notice here there is a group by option. Sometimes you will want to use that. This is not one of those cases. So I think it's pretty obvious when you need to group, but often the directions might tell you. So I want both frequency and relative frequency in the same table, because then I don't have to do two things. So that helps me. These order bys, you don't need to change any of that in there. So I click compute. Now I've got both a frequency distribution. Here are my classes. And again, on here on StatCrunch, you can't see the include and not include. So again, we would use the bracket and the parentheses, but when you go into the options and edit, you see that we've selected to include the left endpoint. So here's the frequency, here's the relative frequency of each of those particular classes or bins. So this would be your answer to part B. So then part C, if we go back to the notes, says construct a relative frequency histogram. So it doesn't ask us for both in this case. So my histograms, I go to graph and then histogram, and I am going to select default rate. And again, I don't need the group by or any of that. Type is where I need to select. I can only do one at a time. This particular example asked me for relative frequency. So I need to tell the bins where to start and the width, just like I did in the distribution. You've got lots of options here, most of which you don't need. What you do need, because this is a display, this is a graph, you need to make sure that you are filling in labels for the axes as well as a title. So my x-axis label would be default rate. The y-axis label would be relative frequency. The title of the graph gives me more specifics about the default rate. So we would say college, university, student loan default rates. And you can choose horizontal lines, vertical lines. You can come back here and edit those things. So if you decide you don't like something or you mislabeled something, once you've got it here, so move this over so we can see it. So now you can see the title, you can see the two labels. Notice how all of the bars are touching each other. They're the appropriate heights. But if I realized I had made a mistake, I could go back to options and edit to fix that without having to start over. So this would be the answer to part C. Again, as I talked about in class, if you're pulling screenshots for me, leave everything on the same screen. So like you can, resize if you need to, and you could get, 4-5 different graphs all on the same screen. And if you include this part, your login, then it's got your name on it automatically already. So if you didn't understand what I was talking about in class the other day, that's what I mean by that. So we finished with constructing all of the necessary graphs. So the very last thing, part D, asks us to describe the shape of the distribution. So when I look at this graph, excuse me, I see that I've got higher bars on the left side and lower bars on the right side. It's definitely not a symmetric graph. I couldn't fold it and have it line up on top of itself. It's not bell-shaped. It's definitely not uniform. So this tells me that this is a skewed graph. And if I look back at the ones that it resembles this one the most. It's got the clumping on the left side, smaller values on the right side. So we would call this graph skewed right. So type that out, and that is our final answer for that. And it's not letting me write because it's being difficult. So we'll just use the pen. So this is skewed, and it is skewed to the right. Make sure that you're always specifying which direction if you are choosing skewed. All right, let me know if you've got questions. Hopefully that gives you a good intro to being able to create these graphs yourself.